Hello, Doctor. Our group members are Asima, Jiva, and myself, Divya, Bimal, Velan, and Kartika. We are from Group 7. Today, we are presenting membrane separation. Let's look at what are the advantages that we can get from membrane separation. First advantage of membrane separation is it do not require a phase change. As a result, energy requirement will be low. The next advantage that we can get from membrane separation is it better for the environment. This is because membrane separation use relatively simple and non-harmful material. The next advantage is it's very simple flow sheet because there are no moving parts.
Membrane processes seldom produce pure product, that is one of the two streams is almost always contaminated with a minor amount of a second component. Not only that, membrane processes cannot be easily staged compared to processes such as distillation. Not only that, membrane processes do not scale up very well to accept massive stream sizes. Moreover, the membrane processes cannot be operated much at room temperature. It is because most of the membrane processes are polymer-based, which the physical integrity constrained by a constant at a high temperature, which is at 100 Celsius. Finally, the membrane processes can be saddled with major problems of fouling of the membrane while processing of the membrane of some feed type.
Okay, moving on to the working principle. Okay, the first working principle we're going to talk about is the membrane process. Okay, first, membrane process can be separated into two. One, the membrane. Two, the process. Okay, what is a membrane? Okay, a membrane is a selective barrier that permits the separation of certain species in a fluid by sieving and sorption diffusion mechanism combination. Separation, meanwhile, is a process achieved by selectively passing one or more components of the stream through the membrane while retarding the passage of one or more components. Okay, there are two types of stream, which are the retentate and permeate. Retentate is the part of the feed that does not pass through the membrane, while the permeate is the part of the feed which will pass through the membrane. Okay, this optional sweep which you see in the diagram is actually can be in gaseous or liquid form. The sweep is to remove the excess permeate inside the membrane. Okay, and there are three different mechanisms which can perform membrane separation, which are size exclusion, pore flow, and solution diffusion. Size exclusion is by having pores or holes of certain size where a specified species can pass and some cannot pass. Pore flow is by selective retardation of the pores when pore diameters are close to the molecule sizes, and solution diffusion is by dissolution of membrane, migration by molecular diffusion across the membrane, and the re-emergence on the other side. Okay guys, I think that is all for the operating mechanism of membrane.
The next is application of membrane separation in technology industries. This involves in microfiltration. It is a type of physical filtration process where a contaminated fluid is passed through a special pot-sized membrane to separate microorganisms and suspended particles from processed liquid. Usually serves as a pre-treatment for other separation processes such as ultrafiltration and post-treatment for granular media filtration. Filters used in the microfiltration process, as shown in the overall setup below, is designed to prevent particles such as sediment, protozoa, or large bacteria from passing through a specially designed filter. The applications of microfiltration is waste treatment, petroleum refining, dairy processing, and also sterilization.
One of the well-known applications which widely uses the technology of membrane separation is dialysis. Okay, in the field of medicine, dialysis is a process for removing waste and excess water from the blood and is used primarily as an artificial replacement for lost kidney function in people with kidney failure. Dialysis is basically works on the principles of the diffusion of solutes and ultrafiltration of fluid across a semi-permeable membrane. Semi-permeable membrane is used in separation techniques that facilitates the removal or exchange of small molecules from macromolecules in solution based on differential diffusion. This semi-permeable membrane is a thin layer of material that contains holes of various sizes or pores. Smaller solutes and fluid pass through the membrane, but the membrane blocks the passage of larger substances, for instance red blood cells and also large particles. The diagram below shows the system of dialysis, and the semi-permeable membrane over here is what we are discussing about. The mechanism that occurs in the dialysis machine is as shown here in the second picture. This replicates the filtering process that takes place in the kidneys when the blood enters the kidneys and the larger substances are separated from the smaller ones in the glomerulus.
So, in conclusion, the membrane separation process has both advantages and disadvantages depend on the process. The stream that passes through the membrane is called as permeate, while the filtered stream is called as retentate. This is very useful in our current daily life. And also, as the example, microfiltration and dialysis. Microfiltration is a process where it is used to separate tiny unwanted particles from the major solution, while dialysis is a process used to separate the excess water and waste from blood. And therefore, in a nutshell, it is very crucial in maintaining our biodiversity. And that's from us. Thank you.